So in graphing real-world data, the scatter plots do not look as perfect as the ones from algebra. In this case, we need to find what we call a best fitting line using a process called regression. So in algebra, when you plotted a bunch of points, they all fell exactly on a straight line. You could put your ruler down and connect dot to dot, and they were all on that same line. When we collect real-world data, it will not be that way, and so we can't connect all the dots with a single line. So we need to find a line that we can put in the plane that is what we call best fitting to all of the points in the data set. So that notation we use in this class for the equation of the best fitting line, which is also called the least squares regression equation, is as follows. So, and now I kind of wrote over the top so you can't even see the hat there. So let's actually highlight these terms because, again, that way they'll be easier to find when they're mentioned in homework as what they're talking about. So again, we've got this y hat of a given value x is going to be equal to a plus b times x. And again, we're going to be using technology to get that equation. So in StatCrunch, again, the steps are here. So under stat, we would go into regression and simple linear and choose our variables and click compute. Again, the calculator, we would start by entering our lists of data. And then in this case, we're going to go into the test menu and scroll down until we find linear regression t-test. And then we'd push enter. And again, we're going to make our screen like the one that's here. So for most of you, next to regression equation, it is probably blank. So it's important that you take a second and actually put a y1 there. And you can do that by hitting your variables button and then right arrow 1 and 1 to type a y1 there. And that should then stay there unless you somehow accidentally delete it. So once that's there, that just gives us a place to store that equation. So then after you highlight calculate and push enter, there's a lot on the output screen, and so you would need to scroll down to see the other values. And on this screen here, I'm just going to put a hat on top of the y. So again, in algebra, we use the same screen and we get actually y equals a plus bx because we're going to get a line that passes through all of the points exactly. So again, in this case, we've got a hat on the y to just say this is going to be an estimated or predicted value of that y. The values that we need to get that equation is this value of a, and then we need to scroll down to get this value of b. Okay? And then that value of a gets put into the equation here for a. This value of b gets put here as the coefficient of x in that equation, and that gives us our least squares regression equation, or our line of best fit. Okay, so this equation is written as y hat of x equals a plus bx. So again, that hat is important as we're looking at this in statistics. As mentioned before, that slope is that b over 1, which is going to tell us on average how much we expect y to change when x increases by 1 unit. And the y-intercept is what we get when we plug in 0 for x. So the output then would be a. And again, in many cases, we're not going to be interpreting the y-intercept because it will be out of the range of what makes sense to talk about, like a baby that weighs 0 pounds or something like that.